So hello everyone. Good afternoon, students. So welcome you all to this session. Yeah, today let's start with the question discussion of this atomic structure. So yesterday we have discussed the theory part of it, and the topics that we have covered yesterday under this lesson, they are the Bohr's atomic model and de Broglie equation, Heisenberg's uncertainty principle, photoelectric effect, quantum numbers, and rules for filling of electrons, right? Now, in today's session, we will discuss some previous year's questions on JEE and NEET on this atomic structure topic. Okay, so let's start with the first question. Yeah, it is a statement type question. So given below are two statements. The statement one says that according to Bohr's model of hydrogen atom, the angular momentum of an electron in a given stationary state is quantized. We have seen that in Bohr's model atom, the angular momentum is the integral multiple of h by 2 pi, right? So it is quantized, and n is an integer. It is quantized. It is limited. It is correct. And statement 2 says that the concept of electron in Bohr's orbit violates the Heisenberg's uncertainty principle. So means they are not overlapping with each other. So they are violating each other, they are saying. So will that statement be correct? So Heisenberg's uncertainty principle says that it is impossible to simultaneously find out the position as well as the momentum of an electron of microscopic particle with absolute accuracy and certainty, right? But Bohr's model of an atom says that electrons are assumed to move in a well-defined orbit with a quantized angular momentum. That's what Bohr's model says. And this implies the knowledge of both electron, that is the position of electron and the momentum of electron. But Heisenberg's principle says that it is not possible to measure both at the same time. So they are violating each other only. So means both the statements are correct. So option C will be the correct answer for this question. Got it? So now let's move on to the next question. Yeah, the energy of an electron in the first Bohr orbit of hydrogen atom is minus 2.18 into 10 to the power minus 18 joule. Its energy in the third Bohr orbit is. So the first Bohr orbit energy value is given, and we know that energy of any n orbit is equal to minus 13.6 by n square electron volt in terms of electron volt. Now we are asked to find out for the third Bohr orbit. That is, we have to find out for n is equal to 3. If n is equal to 3, then E3 will be minus 13.6 by 3 square. That is minus 13.6 by 9. Now in the question it is given that E1 is equal to this value. Okay, E1 is equal to this. But it is given in terms of joule. We have to convert this into electron volt. So to convert this into electron volt, E1 value into electron volt, first let's take this equation. It is in joule. It is equal to 1 electron volt divided by the charge of an electron. That is 1.6 into 10 power minus 19 joule. And it is approximately equal to minus 13.6 electron volt. Okay, so this is E1 value and this is E3 value. Now we have to take the ratio. If I take the ratio for E3 and E1, what we have to take? 13.6 by 9 whole divided by minus 13.6 electron volt. So 13.6 gets cancelled. So it is equal to minus gets cancelled. So we are getting 1 by 9. So its energy in the third Bohr orbit is 1 by 9th of its value. So option C is the correct answer for this. Okay. So let's move on to one more question. Among the following orbitals, in decreasing order, or arrange the following orbitals in decreasing order of energy. So four different sets of quantum numbers are given to us, and we have to find out the decreasing energy level order. So first of all, let us convert this quantum number values to the orbital. So in the first case, the n value is 3 and L value is 0. L value, if it is 0, it corresponds to S orbital. So it is 3s. And here it is 4s. And here 3, if L value is equal to 1, it is p orbital, right? So it is 3p. And here, if it is 2, it is d orbital. So 3d. And according to Aufbauer's principle, we know that the energy starts from 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, and it goes on, right? 1s is having the very lowest energy, then 2s, 2p, 3s, 3p, 4s, 3d, and 4p. Now, put here, 3s is A, and 4s is B, 3p is C, and 3d is D. Now, the decreasing order, the highest value to lowest value is DBCA. It is given in option 4, that is D. It is given in option D. So, option D is the correct answer for this question. Okay. Now, the maximum, coming to the next question, the maximum number of electrons that can be accommodated in shell with n is equal to 4s. With n is equal to 4s. So, how to find out the maximum number of electrons that can be accommodated in a shell? So, in the quantum numbers part, we have discussed yesterday, right? To find out that, we have to use one formula, that is 2n square. 2n square. So this is the formula, and here n value is equal to 4. So 2 into 4 square. So 4 4s are 16. 16 into 2 is 32. So 16 into 2 is 32. So we can accommodate 32 electrons in n is equal to 4 shell. So option B will be the correct answer. Such an easy question, right? Very easy. And moving on to question number 5. The radius of the second orbit of lithium 2 plus is x. The expected radius of the third orbit of beryllium 3 plus is. We know that radius of any nth orbit, it is, let us take for lithium itself, lithium 2 plus, it is equal to R0 into n square by z. Okay, and for lithium, this is equal to x. For lithium, this is equal to x, and for lithium, the orbit value is 2. So n value is 2, and the atomic number Z for lithium is 3. So substitute this. The radius of the lithium 2 plus ion will be equal to R0 into 2 square is 4 by 3. And this is equal to x. From this, R0 is equal to 3x by 4. R0 is equal to 3x by 4. And for beryllium 3 plus, so the n value for beryllium is 3 and the atomic number of beryllium is 4. So it will be R0 into n value is 3. So 3 square is 9 divided by the atomic number of beryllium is 4. Okay. Now just substitute the value of R0 here. Here you will get here as 3x by 4 into 9 by 4. Okay. 3 into 9 is 27x, 4 into 4 is 16. So the radius, expected radius of the third orbit of beryllium 3 plus is 27 by 16x. Option D. Option D is the correct answer. Okay. Now let's move on to the next question. Incorrect set of quantum numbers from the following is. 4 quantum numbers are given. We have to find out the incorrect set. So for a given value of n, L can have 0 to n minus 1 value, right? And m can have minus L to plus L value. And S can be plus half or minus half. And in the first case, you see n value is 4. If n is 4, L can be 0, 1, 2, and 3, right? If L is equal to 0, M is also 0 because minus L to plus L. Here minus 1, 0 plus 1. Here minus 2, 2 plus 2. Here minus 3, 2 plus 3. So in this case, you can see for L is equal to 3, minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. All are there, and spin quantum number, it can be minus half or plus half. Minus half is given. And coming for option B, that is n is equal to 5, L can have 0, 1, 2, 3, 4. And for L is equal to 0, sorry, L is equal to 2, M can be minus 2, minus 1, 0, plus 1, and plus 2, right? For L is equal to 2. But here you see only 4 numbers are given. 0 is not there in the option. So it is the incorrect set. It is the incorrect set where it is a correct answer for this question. And coming to option C, and L is equal to n is equal to 4. L can be 0, 1, 2, 3. And here L value is 2. L value 2 means all the 5 numbers, magnetic quantum number has to be there, and it is there in the question. And coming to the last option, for n is equal to 5, 0, 1, 2, 3, 4. And here L value is 4. Sorry, 3. So it is minus 3, minus 2, minus 1, 0, plus 1, plus 2, and plus 3. So all these are there for m value, magnetic quantum number value, and spin quantum number is also given as plus half. So all other sets are correct except B. Okay, so option B is the correct answer because 0 is not there. I hope you have understood this question. Now let's move on to the next question. The relation between n, m, that is the number of permissible values of magnetic quantum number for a given value of azimuthal quantum number L is. We know that the relation between the magnetic quantum number and azimuthal quantum number, it is nm is equal to 2L plus 1 value. So what is 2L? 2L is equal to nm minus 1. And what is L? It is nm minus 1 by 2. So L is equal to magnetic quantum number minus 1 by number of permissible values of magnetic quantum number minus 1 by 2. So in which option D? D is the correct answer. Okay. Now let's see the next question. So you have to match list 1 with list 2. Yeah, the magnetic quantum numbers n and L are given. We have to find out the corresponding orbital and match it with it. So here n is equal to 2. So n is equal to 2 means, and L is equal to 1. L is equal to 1 for p orbital. If L is equal to 0, it corresponds to s orbital. If L is equal to 1, it is p. If it is 2, d. If it is 3, it is f. Now here it is 1, so it is 2p. And here it is 3d. And here it is 3s. And here it is 2s. Okay. So A corresponds to 3. B corresponds to 4. C corresponds to 2. And D corresponds to 1. So option A will be the correct answer. Option A will be the correct answer for this question. Okay. So now let's move on to the next question. If the radius of second Bohr orbit of the helium plus ion is 105.8 picometer, what is the radius of third Bohr orbit of lithium 2 plus? Yeah, again we have to take this relation. Rn is directly proportional to n square by z relation. So this relation we are going to use here in this question. So we know that for lithium, you have to find out for lithium, right? And it is third Bohr orbit. N value is equal to 3. and Z value for atomic number for lithium is also 3. And the Z value for helium, atomic number of helium is 2, and it is the second Bohr orbit, so N is equal to 2. So let us take the ratio. R3 of lithium 2 plus we have to find out with R2 helium plus known value. Okay, it will be equal to, so what is R3? R3 is directly proportional to 3 square by 3, and R2 is equal to 2 square divided by 2. Now, if you substitute here, what we will get? We will get 3 square by 3 and into, just reciprocate it, 2 by 2 square, right? So, which is equal to 9 by 3 into 2 by 4. Got it? This is the value. And the radius of the second Bohr orbit of helium plus is given. So what we can do, we can substitute that value here in place of R2, that is 105.8 picometer, which is equal to 9 by 3 and 2 by 4. Now bring this to the other side. R3 of lithium 2 plus will be equal to 105.8 okay, into 9 by 3, we can cancel it here, it will be 2, so into 2. So on solving this, we will get 158.7 picometer. 158.7 picometer as the answer. Got it? So here also you can solve, that is 13 and 3 by 2 into 105.8 will give 158.7 picometer, which option A is the correct answer for this question. Okay. Now coming to the next question. Yeah, it is assertion reason type question. Assertion says that energy of 2s orbital of hydrogen atom is greater than that of 2s orbital of lithium. Energy. So as the atomic number increases, okay, as the atomic number increases, energy of the species is getting more negative. This is the concept. So for hydrogen atom, atomic number is 1, and for lithium atom, atomic number is 3. Okay. So as the atomic number increases, energy becomes more negative. Energy and the atomic number, they are inversely proportional to each other. Okay. So energy of 2s orbital of hydrogen atom is greater than that of, yeah, it is becoming more negative. So that is what is given there. More negative means lithium will have the more negative value, and hydrogen will have the kind of positive value. That positive is greater than negative. So that is given an assertion. So it is correct. And reason says that the energy of the orbitals in the same subshell, because both are 2s, right? So their same subshell decreases with increase in the atomic number. Yeah, energy decreases with increase in the atomic number. That is the correct reason. So both A and R are true, and R is the correct explanation of A. Okay, fine. Let's move on to the next question. The number of radial nodes and total number of nodes in 4p orbital respectively are. So we know to find out the radial nodes, right? So the total number of radial nodes can be calculated using the formula n minus L minus 1. Okay, and the orbital is 4p. And for 4p orbital, n value is equal to 4 and L value is equal to 1. Okay, substitute this here, and what we will get? We will get n is 4, L is 1 and minus 1. So 4 minus 2 is 2. So number of radial node is equal to 2. And the total number of nodes. Total number of nodes can be calculated using n minus 1 formula. So n value is 4 minus 1. So it will be equal to 3. So radial node is 2, total number of node is 3. So option A is the correct answer. So here you are studying these two formulas from this question. Got it? Very easy. Now let's go to the next question. Which of the following statements are correct? Statement A says that the electronic configuration of chromium is argon 3d5 Yes, it is correct because the atomic number of chromium is 25. Then it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d5 is the configuration. So here this is the configuration of argon, and since d orbital is half filled leading to the more stable configuration, one of the electron from 4s orbital jumps into the 3d orbital giving rise to this configuration. So that is correct. Statement A is correct. And that is given in all the option, obviously it is correct. The magnetic quantum number may have the negative value. So what is the formula to find out the magnetic quantum number? It is minus L2 plus L. So it contains both positive and negative value. So statement B is also correct. Coming to statement C, in the ground state of an atom, the orbitals are filled in order of their increasing energy. Yeah, we have to follow the Aufbau's principle, right? The electrons are arranged in the increasing order of their energy level. So in that way only the electrons are filled. So it is in accordance with Aufbau's principle. That is also correct. Statement D says that the total number of nodes are given by n minus 2. No. Total number of nodes are given by the formula n minus 1. So D is not the correct statement. So A, B and C, they are the correct statements, in which option D is the correct answer for this question. Okay. Now moving on to the next question. Yeah, which is also of statement type. We have to find out the correct statements again. Statement A says that the principal quantum number n is a positive integer with values of n is equal to 1, 2, 3. That is correct. Principal quantum number n value starts from 1, 2, 3 only. And azimuthal quantum number can have values L is equal to 0 to n. No. The azimuthal quantum number L can have values from 0 to n minus 1. But it is given as n. So it is wrong. It is not the correct statement. And coming to C, magnetic quantum number m, L for a particular L has 2L plus 1 value. That is also correct. Magnetic quantum number, it will be equal to 2L plus 1. That is also correct. Total number of orbitals can be calculated using this formula. And coming to the next statement, plus half and minus half are the two possible orientation of electron spin. Yes, no other spin is possible. Only these two are the values. Orientation. Plus half corresponds to clockwise direction. Minus half corresponds to the anti-clockwise direction of the spin. And the last E statement, for L is equal to 5, there will be a total of 9 orbital. No. So M is equal to 2L plus 1, right? Magnetic quantum number. Total number of orbital can be calculated using 2L plus 1 number formula. So L value is equal to 5. So it is 2 into 5 plus 1. So it is equal to 11 orbitals. So but only 9 is given there. So it is not the correct statement. So A, C and D are the correct statements, and it is given an option C. Okay. Fine. Let's move on to one more question. Yeah, the number of radial and angular nodes in 4D orbital. So radial nodes formula is n minus L minus 1. For 4D orbital, n is equal to 4 and L is equal to 2 for D. So it will be equal to 4 minus 2 minus 1, in which we are getting 1 as the total number of radial nodes. And the total number of angular nodes, it is equal to L. The formula to find out the total number of angular nodes is L. L is nothing but 2. So 2 is the answer. So 1 and 2. Option A is the correct answer for this question. Okay. Fine. Let's move on to one more thing. If the radius of the third Bohr orbit of hydrogen is R3 and the radius of fourth Bohr's orbit is R4, then the relation between R4 and R3 is. What is given there? What is the relation? Rn is equal to R0 into n square by Z, right? Now for hydrogen atom, n value is equal to this third Bohr orbit. So n value is 3 and the atomic number of hydrogen is 1. Substitute here, you will get R3 as R0 into 3 square is 9 by 1. So from this R0 value is equal to R3 by 9. Okay. Now coming to the fourth Bohr's orbit, that is R4. So for R4, n is equal to 4. And again, Z is equal to 1. So R4 will be equal to R0 into 4 square. That is 16 by 1. So R0 is equal to R4 by 16. Okay. Now what we have to do? We can substitute the values of R0 there, right? We can substitute the values of R0 in place of this R4 equation. R0 is equal to R3 by 9 into 16 by 1. So this is the relation that we are getting. And from this R4 is R3 by 9 into 16. Or else we can say that R4 is equal to 16 by 9 into R3. Okay. So it is given in option B. The relation between R4 and R3 is option B. Okay. Yeah. Let's move on to one more question. The minimum energy that must be possessed by photons in order to produce the photoelectric effect with platinum metal is. So what is the minimum energy? It is nothing but the threshold energy. Threshold frequency is the minimum amount of energy that is required to eject an electron from the metal surface. Okay, in the photoelectric effect. So we have to find out that minimum energy. We can say that minimum energy is equal to the work function. It is equal to the work function, which is represented by W naught, and this W naught is equal to H nu naught. This is the minimum energy required. So the minimum energy is equal to H nu naught in terms of joules. Okay. H value is given as 6.6 into 10 power minus 34 joules second. And threshold frequency is given as minimum frequency. Threshold frequency is nu naught. Minimum frequency that is coming. It is 1.3 into 10 power 15 per second. So if we solve this, we will get 8.58 into 10 to the power minus 19 joule as the minimum energy value for this system. Okay. So it is given in option C. Just direct substitution. You are using this formula and just directly substituting. Minimum energy means it is H nu naught. Minimum energy is nothing but H nu naught. Minimum frequency is represented by H, nu naught. You multiply H and this nu, you will get E. E is equal to H mu, right? So that relation we are using. So option C is coming out to be the correct answer for this question. Let's discuss one more question. A certain orbital has no angular nodes and 2 radial nodes. The orbital is. So we know that angular node is equal to L. And if it is equal to 0, means L is equal to 0 corresponds to S orbital. And if L is equal to 1, it is P. If it is 2, it is D. If it is 3, it is F. So L is equal to 0 corresponds to S orbital. Okay, this represents the S orbital. And it has 2 radial nodes. So the number of radial nodes can be calculated using the formula n minus L minus 1. And this value is coming out to be 2. Okay. So here, if you see, L value is equal to 0 minus 1 should be equal to 2. Okay. So if I put what x, let me write here as x. Okay. So x is equal to 2 plus 1, which is equal to 3. So the n value or the x value, let me write here as n itself. Okay. We can keep this as n itself. So n minus 0 minus 1, where n is equal to 3. So n is equal to principal quantum number is 3 and azimuthal quantum number is 0 and it corresponds to s orbital. So the answer is 3s orbital. So option B. So 3s orbital has 0 angular node and 2 radial nodes. Okay. So with this, let me close the question discussion session of this atomic structure. I hope the previous year's questions of this JEE and NEET that I have discussed with you on atomic structure topic is very useful for all of you who are all watching this. So we can meet up in the next session with a new lesson. So till then, take care. Thank you so much for listening the lecture and advance Happy New Year to all of you. Okay. Thank you. Bye-bye.